Hello everyone! In this tutorial I'm going to show you how to use regular expressions in JavaScript programming. If you're interested in learning how to build regular expressions, you should watch my first two regular expression tutorials that I'll put a link to in the description. In JavaScript, there are two ways to form a regular expression. One way is to create a regular expression object by using new, RegExp, and then in parentheses you can specify the regular expression as the first parameter. So let's say we said \d plus. We'll need to escape the backslash, which is in a string, and the second parameter will be the flags. So if I wanted to make a global flag, I would add g as the second parameter. Now the second parameter is optional. I can leave this out and it'll just be the regular expression with no flags. The other way to write it is, as you see here, you can make a /, then the regular expression you want, and then another /. And if you want to put a flag, you put a g at the end of there. Now we will look at the test function in JavaScript. If you take a regular expression, for example \d plus, and you say .test, and then a string, let's say 1, 2, 3, it will return whether or not this regular expression is matched anywhere within this string. So if I run it on 1, 2, 3, it will say true since there is a substring that matches one or more digits. If we said A1, B2, C3, it would also say true because there are also numbers within this string. If we said starts with \d plus and ends using the anchors for beginning of string and end of string, then it will say false since this string does not fit this pattern. If we had a number that started and ended with a digit and had only digits in between, then this will return true. If we say bridge as a regular expression, .test abridged, it will return true since bridge is within the string bridge. If we wanted to check if the word bridge was contained within this string, we could use word boundaries. So for example, at the beginning of the string we put \b, and at the end of the string we put \b, and now we'll check if the word bridge is within this string. If we had the word a bridge as the string, then the word bridge is in here. We have a word boundary at the left side and a word boundary at the right side since it's the end of a string, and it will return true. Now let's create a regular expression for United States phone numbers. Okay, so we will call it phone. So we'll let phone equal the regular expression, 3 digits, an optional hyphen, so hyphen and question mark to make it optional, and then 3 digits again, and then another optional hyphen, and then 4 digits. Now this will match many forms of phone numbers, but not all. We can make test cases to see what it will match. So let's say let tests equal an array. The first one we will make a phone number where we have 10 digits and no hyphens. The second we will put hyphens in. And for a third example, we will make an invalid phone number. So let's make one with 9 digits. Let's make one with 11 digits. And let's make one with the hyphens in the wrong place. Now we can check if each of these phone number strings match this regular expression. We can say tests.map. We will make an arrow function, meaning that the parameter is x. We'll have an arrow, and the return value will be phone.test x. So x will be referring to a string within the array tests, and it will check if phone.test x is true or false, and it will store that in an array. It will create a new array that says true, true, false, true, false. Now we notice we wanted the first to be true, but this one we did not want to be true. The reason that it returned true is because it contains this string where we have 10 digits, but it's not exclusively 10 digits. So we want to add anchors to the beginning and end. So note that this regular expression should match the entire string and not just a substring. Now if we run these tests again, we will see that the last three return false. Let's say we add more tests that we want to work with. We will add another valid case where they put the area code in parentheses followed by a space, then 3 digits, and then 4 digits. And another valid case is +1 and then a phone number. And another valid case is +1 and this new form of phone numbers. Now if they have a country code which is not +1, it should not match this regular expression. And if they put too many numbers in the parentheses, it should also not match the regular expression. And we can make many more test cases, but we will start with these. Now we'll need to update the phone regular expression to work with the new case. First, we will need to allow it to have parentheses around the first 3 digits. We can make a optional open parentheses over here by saying / open parentheses and a question mark to make it optional. And over here, instead of a hyphen, we can have a closed parentheses and a space. So we can put in parentheses to make a group, or, which is the vertical bar, and then a closed parentheses followed by a space. So now it should match this string, but let's say we want an optional +1 at the beginning. We can add at the beginning, in parentheses, +1 space, and put a question mark to make that optional. And now let's press enter and run our tests again. Now we see true, 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 false, 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 false. We had 5 trues and 5 falses, and that is exactly what we expected. So our regular expression is working correctly. Another useful way to use the test function is to check if there are words that you disallow. Let's say you have a comment section and you do not want to allow links within a comment. Let's say the body of the comment equals some string that contains a link, let's say example.com, somewhere in the comment, and we want to check, does this string contain a link? So we can say link, we'll make a regular expression that will say HTTP and an optional S, and then a colon will be one way of noting a link. Another way is if it contains a www, and we will also disallow the word JavaScript : in our comments. So now we can use link.test body, and it will tell us whether there's a link in the string or not. So if body was equal to something without a link, then if we do link.testBody, it will return false. Next, I'd like to talk about matching and groups. If we have a regular expression, let's say \d+, and you use the .exec function to execute on a string, let's say we have ID : and a number, that it found the number. It also returns the index of where it is found and the full input. Okay, let's say we have a string that contains an ID, which is a number, a gender, and an age, which is also a number. And now let us make a variable to store this number regular expression. If we say number.exec string, it will return the first match. If we run it again, it will return the first match again. And because this regular expression does not have a global flag, it only returns this one result. If we want to return all numbers, we will have to use the global flag. So let's say let numbers equals \d plus and add the global flag. Now if we say numbers.exec string, it will return the first result. If we run it again, it will return the second result. If we run it one more time, it will tell us null. And now it will start over from the beginning. If we continue, it will start with the first result, and then the second result, and then again null. If we had a capturing group inside of the regular expression, for example, we'll call it labeled num equals the regular expression slash \w plus colon \d plus global. It will match a word and it will be captured with parentheses, and then a colon, a space, and then a string of digits, which is also captured in parentheses. Now if we say labeled num dot exec string, the first parameter is the entire string, including all caption groups and all text in between. The second parameter is the first captured group, and the third is the second capturing group. If there are more caption groups, they'll be added in as further indices in this list. So now if we had a variable referring to this result, we would be able to access the full match with the result sub 0, the first capturing group with result 1, and the second capture group with result 2. And now note, the first time we ran it we got the ID, and the second time we ran it we got the age, because they both have a string of digits as the match. If we want to return all results, first I will make this null. Let's say I want to create a dictionary, meaning a mapping, with all labels as keys and the numbers as values. So the output I'm looking for is ID colon 432432, comma, and then age 21. And this is a mapping, so it returns it in no particular order. Age is 21, ID is 432432. And if we had a dictionary set to equal this object, we can access an ID with ID and an age with age, and it is a very quick operation. Let's say we want to build one for the string that we saw earlier. Okay, so let's create a new dictionary object, which will be empty by using the empty curly braces, and then a while loop. We'll need to run the exec function multiple times inside this loop. So we will say labeled num dot exec on string, and make sure that is not equal to null. Now this not equal to null check is actually optional, since by default a while loop will stop when it reaches a null value. We will need to use the result of this inside of our loop, so we can say result equals this and put this in parentheses to make sure that it evaluates to be what we are assigning result to make sure that is not equal to null. Now we set the dictionary's key to be the result sub 1. Result sub 1 will be the string of word characters from a regular expression, since that was the first group in parentheses. And now the value will be result sub 2, which is the second caption group, which is the numbers. Now if we press enter and we look at what dict has right now, you see that it was empty over here, and this while loop populated the dictionary to contain age 21 and ID 432432. The next function we'll be looking at is the match function. The match function is very similar to the exec function, but you call it on a string. So you say string.match, and then a regular expression, so we'll say number. This will return us something that looks similar to what we saw for exec. It will tell us the match, and also further caption groups would show up as further indices in the array. One main difference about string.match is if you are using a global regular expression with the global flag turned on, instead of returning the matches one at a time, it will return to you a list of all matches. So if we say string.match numbers, which was the regular expression we made that had a global flag, it will just return the numbers that were returned. And interestingly, if we use labeled num, which is the regular expression that had caption groups, it does not even mention the groups that were captured. It only matches the full text, and that is all that will be returned using the match function. If you want to use caption groups, you'll need to use the exec function and use a loop. Otherwise, if you're interested in just a list of matches from a string, you can use the .match function. And of course, if you only have one result, you can use .match or .exec, and both will give us this type of result. Next, we will look at the replace function. The replace function is one of the most useful uses of regular expressions in JavaScript. Let's say we use hello world, and we say .replace world with YouTube. This is without using regular expressions, just an example of the replace function. It will take the first parameter and find it within the string and replace it with the second parameter. If we said hello, replace L with Y, you'll notice that it only matches one result. It only matches the first occurrence of L that it finds. If we wanted it to match all occurrences of L, we would have to make a regular expression. Instead of saying L in quotation marks, we will say L inside of slashes, and we will enable the global flag. Now, all occurrences of L are replaced with Y, since the global flag tells it to not stop at the first match and check for more matches. Now let's look at the string we had in earlier examples. We have ID, gender, and age. If we want to replace the first string of numbers with a 0, we can say replace \d plus with 0. If we want to replace all numbers with 0, we can set the global flag and it will replace all numbers in the string with 0. For this next example, I'll replace the word male with the letter M. So I'll start by saying string.replace. In the regular expression, I will use just male, all lowercase, but I'll set the case-insensitive flag to be enabled. This will mean that it will match male all lowercase, male all uppercase, or some mix of uppercase and lowercase. It will ignore the case of the letters. I'll also set the global flag to be true, which will not make a difference in this case, since the word male only occurs one time, but if it occurred many times in this string, it will replace all of them. Now we'll set the replacement text to be the letter M, and run this, and we'll see that gender is now M, since it contained male with an uppercase M and the rest is lowercase, but we were using a case-insensitive flag. If you want to use a capture group in a replacement, that is also possible. If we said string.replace, and then we said \d in parentheses, and then \d plus, so the first digit is now in a capturing group, and then we set the global flag and replace that with $1. $1 will refer to the first capture group, so we'll refer to the digit that is in parentheses here. So now you'll see that each number is replaced by the first digit of that number. Now let's look at the original string again. Let's say I wanted to swap the labels with the values. Let's say I wanted the result to be 432 colon ID, male colon gender, 21 colon age. Is this possible with a regular expression? Pause the video if you want to try figuring it out on your own. In 3 seconds, I will explain how to do it. We'll be using string.replace. First thing we need to do is match the word, which is the label. We can use \w plus and put that inside of a caption group. And then a colon space. And then we need to match numbers or letters, so we can use A to Z or 0 to 9 plus and put that in a caption group as well. And then set the global flag to be on. The replacement will be $2, which is the second capture group, and then a colon space, and then the first capture group. So now, the reason why this will swap them is because the first group is on the left here, and the second group is on the right. And now in the replacement, we put the second group first, and then the first group second. So if we run this, we'll see we got the desired output. Now one more thing about replace is that the second parameter does not have to be a string. It can actually be a replacement function. Let's say I want to make all of the labels be uppercase. I can use string.replace. We will say \b for word boundary, and then one or more word characters, and then a colon. That will match a label, which is preceded by a colon. We will set the global flag to be on. And then for the replacer, we will make a function. We can write function and the parameters x. X will refer to the string that is matched for every string that is matched. And then we will replace it with x.toUppercase. So now all of the labels are now uppercase, since this function takes the match, converts it to uppercase, and returns that as the replacement. Another way of writing this is with an arrow function. If we want to be more concise, we can take away the word function here and replace it with an arrow between the parameters and the curly braces. We can also remove the word return if we remove the curly braces. So now we can put this all in one line, and also these parentheses around the x are also optional. So altogether we have x arrow x.toUppercase, and this is equivalent to function x return x.toUppercase. If we run this, we'll see we get the same result. Now let's write a replacer to increment the age. So our original string, we have the age being 21. Let's say we want to make it so that age is now 22. We can say string.replace age, and then in parentheses \d plus. Now the replacer for a function with a caption group will take more than one parameter. The first parameter will be the full match, ignoring all caption groups and containing all text from the beginning of the match to the end of the match. All consecutive parameters are caption groups within the match. So the second parameter is the first caption group, and the third parameter is the second caption group, etc. In this case, we only have one caption group, so the first parameter will be the match, and the second parameter will be the captured group, so the digits. So we'll say num. So now we'll make an arrow function, and the return value for this arrow function will be age, colon, and then we want to concatenate that with num plus 1. This is not quite enough though, because num is actually a string of numbers, so if we concatenate that with 1, it would just put a 1 on the end, so we get 211. There are a few ways that we can avoid that issue. One way is to use parseInt, which will parse the number as an integer. And if it is 21 as a string, it will return 21 as an integer. So it will be the numeric value 21. If it is not necessarily a whole number, we can use parseFloat to parse it as a floating point number. Another way we can do this is just by using the number function with an uppercase N. This will create a number using the string 21, and it will return the numeric value 21. Another way to do this, which makes your code a bit harder to understand, but is the shortest, is just use a plus sign before the variable, and it is a unary operation that can only be called on numbers, so if this is a string, it will convert this to a number first. So I will use the number function to make it most clear what I'm doing. So now we have the number 21 plus 1, which will give us 22, and then it will be concatenated with age, colon, to replace the full match. Now if we run this, you see that age was incremented to 22. Now at the beginning of the video, we mentioned that there are two ways to create a regular expression, by using the slashes or by using the new RegExp function. You might be wondering, why do we need the longer way of doing it? Well, one reason we need it is to use dynamically generated regular expressions, meaning we create them based on input in our program. Let's say we want to create a function, remove attr, should remove an attribute from the string. The first parameter we'll call text, and the second parameter we'll call attr. Text will be the string which we'll pass to the function, and attr will be the attribute that we want to remove. We can say let re, which will be our regular expression, equals new regexp. We'll have a word boundary. We need to do a double backslash here because it is in a string, and then concatenate that with attr, and then concatenate that with colon 0 to 9 a to z plus, and then the second parameter will be gi for global and case insensitive. Now what we will return from this function is the text, but replace the regular expression with an empty string. I'll replace the function with the version with a space after the colon. If we call this function, you see it removed the id attribute, although we have an extra comma space here. If we look at remove attr with gender, we'll remove gender. We also have an extra comma and space on before and after, which there should only be one of, and we also have age, and we have a comma and space that before age that was not removed. So how can we make it so that it will remove those commas and spaces automatically? I will overwrite this function, and first thing we'll do is remove all commas and spaces, which are optional, from before and after. So now what we have here is an optional comma or space before the attribute, and then an optional comma space after the value. This will work for ones on the end, where we want to remove from both sides, but in the middle, it will not work. See, if we say remove attr and id, it will look fine, but with gender, it will remove both sides. So we will not have any comma. In our replacement function, we can take care of that case. We can say x, which will be our string that is matched, and we actually have two caption groups already, which we can call A and B. So x will match the full text, including the commas and the attribute, the value, and the end comma. A will be the first caption group's result, B will be the second caption group's result, and if the optional group is not matched at all, it'll just be set to the value undefined. So if A and B both have a comma and space, then we want to keep a comma and space as the replacement. However, if one of them is undefined, we will not. So one way we can write this, we will say if A is equal to B, and the only case where that would be true is if A was a comma and a space and B was also a comma and a space, then we will say return a comma and a space. And then we will say else. So in the case where one of them is undefined and the other one's not, then we will say return empty string. So now let's run this function again. Let's say remove attribute ID, and now let's try removing the attribute gender, and now let's try removing the attribute age. And for all three cases, the commas were correctly replaced. At times, dynamically generated regular expressions will not quite work the way you expect. Okay, let's say we had this expression. Let's say we want to write a function that will remove all occurrences of text, and we have the text to remove as a parameter. We'll have the text as the first parameter. If we say new RegExp on the text to remove and set the global flag to be on, and then we say return text dot replace, we'll say let re equal this. We'll replace this regular expression with an empty string, and now if we call this on the expression and pass it 2, it will remove all of the 2's from the expression. And same if we use space, it will remove all the spaces. But what if we had the expression 2 plus 1? Will this remove the 2 plus 1 from the expression? It did not. Why did it not remove the 2 plus 1? It's because in a regular expression, the plus sign is a special character. So what we asked it to replace was 2 followed by any number of spaces, then another space, and then a 1. It did not read this plus sign as a plus sign. If we want to replace 2 plus 1 in this text, we would have to have it escaped when we make this regular expression. The way we can do that is by escaping our input first. So in this function, before we create the regular expression, we'll need to put a backslash before special characters. And since we need to put a string into this regular expression function, we have to make 2 backslashes, so we escape the backslash and it will keep the backslash in the string. So we will say escaped. We'll make a variable called escaped, and we'll set that equal to the text to remove dot replace. Now we'll need to list off all of the special characters, which would be dot, star, plus, hyphen, which needs to be escaped inside of brackets, and a question mark, a caret symbol, $, curly braces, parentheses, square brackets, and we'll escape the end square brackets as interpreted literally, and then a backslash, which also need to be escaped, and then close this off, and we will have the global flag, and replace that with backslash backslash, and then the full text. So instead of creating a whole caption group for the entire text, another way we can do this is by using $ampersand. $ampersand means the whole match string from the beginning of the match to the end of the match. So when we say backslash backslash $ampersand, it will put a backslash before every special character. Now if we put escaped as the regular expression and we run this again, we do remove all on 2 plus 1, it was able to remove 2 plus 1 successfully. I will copy this over here so you can see more specifically what this replacement is doing. If we have 2 plus 1, we get a backslash before the plus. Any symbols that are special, it's like a star and a dot, we'll make a string that contains a lot of these. And we will do the replacement. You'll see that every occurrence of a special character was escaped with a backslash. So now this is a valid regular expression where all of the characters in the input are treated as literal characters and not as special symbols in regular expressions. It might be useful in your programs to create a function that will do this for you. So you can create a function and call it RegEx Escape, or anything you really want, and you can take an input and say return input.replace, make this replacement, and end the function. So now anytime we need to escape text for regex, we can, instead of saying this whole line, we can just put regex escape as the function and say text to remove. And now this will perform the same actions. And it looks much cleaner. The next function I want to talk about is the search function. The search function on a string will find the first occurrence of a string of text. So if I said hello.search E, it will tell me that it occurs at index 1. H is index 0 and E is index 1. It can be a string of text, so you could say LO and it'll tell me at index 3, that's 0, 1, 2, 3, we have the string LO starting. Now this parameter can also be a regular expression. So let's say I had a string where I'm not sure where the numbers are in the string, but we know that there are some numbers in the string. We can say .search and then say \d, and this will tell me that the first digit occurs at index 8 within the string. Search will only give me the first match. It does not keep searching for further matches after the first one. Now a quick warning about using global regular expressions using test or an exec loop. When you're using the global flag, JavaScript will store the last index where a match was found. So if you remember before, when we had the labeled number and we used labeled num.exec string, it returns the first match and then the second match and then the third match. The way this works is by storing in labeled num the last index. Right now it's set to 0. If we run this once and check last index again, now it's equal to 10. The last index where this global expression was matched is at index 10. So now we'll start from index 10 when it looks for another match. So if I call exec again, now last index is set to 33, so we'll continue from index 33. And if we call it one more time, we'll get null, and last index will now be 0, since we will restart at the beginning of the string. So you have to be careful when using global expressions, since it does not give the same result every time. This can give very confusing results, especially when using the test function. Let's say we want to find digits inside of a string. We said hello 1, 2, 3. It will say true. We already have numbers, which has a global flag, and we say numbers.lastIndex, it's set to 0. If we say numbers.test hello 1, 2, 3, it will say true, and now numbers dot last index is set to 9. That means that the next time we use the test function on numbers, it will start from index 9. So if there are no numbers after index 9, for example, if the numbers were at the beginning of the string, and we call the test function, it will tell me false, even though there are actually numbers in the string. If we call this function again, it will say true, since it started over from the beginning. The way you can make sure to avoid this is by not using global regular expressions when using the test function, unless you specifically are using the last index as part of your program. Also, when you're looping through values returned by an exec function, if you use a global variable, you have to make sure that you know where you're starting, what the last index is. A good idea to fix this problem, if you need to use a global expression, is by setting the last index to 0 before starting the loop. So you could say numbers.lastIndex equals 0, and then start printing results. The last topic I'm going to talk about in this video is using Unicode symbols, which take 2 code points. For example, the smiley face emoji contains 2 code points. So if we said .length here, we will actually see that's 2 code points. If we say 0, we get this character, and 1, we get this character. But if we put them together and say 0, and then concatenate that with 1, you'll get the smiley face. If your regular expression uses the smiley face, or another Unicode symbol that takes up more than 1 code point, it will give unusual effects in regular expressions. So let's say we had this string, smiley face, smiley face, smiley face, and we test if the smiley face occurs 3 times, this will return false, since what this really means is take the first code point and then find the second code point 3 times after that, and that's not what we have here. Here we have both code points 3 times. So this will return false. If we use the Unicode flag by putting a U after the slash, then this will now return true and give us correct results. The Unicode flag allows you to use more types of symbols and interprets them as characters as opposed to individual Unicode symbols that make up the string. I hope this introduction was useful. Please let me know in the comments what you'd like to see more of. If you liked this video, please give it a thumbs up and subscribe, and I'll be making more content just like this. Thanks for watching. Bye!